Hello everyone, my name is Jason Cronin, and in this presentation we'll be covering the history of navigation. It's hard to imagine in our current time someone not being able to find their way to almost any place in the world. Being that all most of us have to do is ask our phone, and it will not only find us multiple routes, but give us the fastest and least expensive, along with the current traffic conditions to our destination. How did this amazing technology come to be? And how did anyone ever manage to find their way before it? These are just two of the questions we will be able to answer as we look into the history of navigation from early cartography to our current abilities with GPS technology. In doing so, we will gain insight into what the reasons are for us wanting and needing this technology and how it will benefit civilization through time. Let us first start by defining what navigation is. The process or activity of accurately ascertaining one's position in planning and following a route. When we look back into early human history, after the agricultural revolution, where humans began to settle into small communities rather than continuing a nomadic lifestyle, we can find the birth for the need of navigation. As communities grew and others began to take root within relatively close proximity, there became the situation of resource trade. As early as 2300 BC, civilizations in Mesopotamia were developing the first tool needed for navigation: maps. Through the development of maps, we were able to provide the special orientation required to ascertain one's position accurately. This is the first step to navigation, the ability to define where you are starting from to be able to plan where you want to go. The technology of map making is known as cartography. Cartography can be concisely and classically defined as the art, science, and technology of map making. The popular associations of the word with techniques of map making are a reflection of its lexical roots in carte, French for map, and graffiti, Greek for writing. The history of cartography is very long and detailed, and for the purpose of this paper, we will touch on some of the major advancements in this technology as it relates to its use in navigation. As stated, the civilization of Mesopotamia provided us with the oldest recorded map from around 2300 BC. It's pictured on the right. A Mesopotamian map of intermediate scale, though as such small dimensions that it can be held in the palm of the hand, is the well-known Akkadian map from the Nuzi and dated ca. 2300 BC. This map depicts locations of settlements along the geological markers, such as mountains and watercourses, that a person utilizing the map could use for orientation when trying to get from point A to point B. These early maps lacked both scale and directional orientation. The surviving maps from this time were drawn on clay tablets, making them very difficult to copy. The next major advancement in cartography for the purpose of navigation comes to us from the Greeks. Not only did they form the theory of the Earth being a globe rather than flat and devising a way to measure the circumference of the Earth with remarkable accuracy, they also gave us the understanding of one of the most fundamental tools in accurate navigation: the concepts of latitude and longitude. By the 2nd century BCE, Greek mathematician Hipparchus had suggested that a proper map of the Earth would feature lines of latitude running east and west and parallel to each other from the equator up and down to the poles. These would be intersected by longitudinal lines running north and south, although not in parallel. Instead, these lines would be farthest apart at the equator and then steadily converge until they united at the poles. Viewed this way, the planet was wrapped in lines, and a place on Earth could be defined by its location on the grid. The understanding of latitude and ways to measure it had been around for some time. Using the stars, moon, and sun, early explorers could use tools such as an astrolabe to calculate their latitude by the angle from the north polar star and the horizon. It was decently accurate. Longitude, on the other hand, proposes a much more significant problem. Contributions from China. Another early tool of navigation was the magnetic compass. The early accounts of this technology is in China in 1111 AD, where a metal needle is rubbed on a lodestone and set on a floating leaf, would point and could be used to determine direction. Point south could be used to determine direction. The invention of the compass made exploration a year-round endeavor, since explorers no longer needed to rely on celestial bodies in the sky. Navigation could be more predictable even in harsh weather or even just cloudy nights. With the use of the compass, maps began to be more accurate, and cartographers could get more accurate information in regards to directionality and distance by using them. Until 1600, it was believed that there was a massive magnet at the top of the world. Through experiments with miniature earths carved from lodestones, William Gilbert was able to make observations with his compass needle, which pitched upward and downward directions dependent upon which pole he was closest to, and lie level at the equator. This data proved that it was not a magnet at the top of the Earth, but the Earth itself, and led to the study of the Earth's magnetic fields. The next major advancements in navigation came in 1766, when Nevil Maxley published his Nautical Almanac. This gave charts to celestial bodies as viewed from Greenwich, England, which gave navigators around the world the ability to measure using a sextant and knowing what time it was in Greenwich, so that they could very accurately calculate their longitude. By knowing both the time in Greenwich and the time in their location, they calculated based on the time difference. An explanation of that is that the Earth is a near sphere, which makes a complete rotation on its north-south axis once every day. Thus, our planet rotates 360 degrees every day, or 15 degrees in each of the day's 24 hours. This means you can figure out your east-west location relative to some reference point on land if you can answer two simple questions. First, what time is it where you are? Second, at that same moment, what time it is at your land-bound reference point. We'll also note that Greenwich, England, is where the International Prime Meridian is located. That is 0 degrees latitude, where everything works from now. We'll now jump to 1891. Cartography has advanced all around the world, but there is no consistency between countries, with all of them producing maps in their own style and scale. Albert Peck, a German geographer, suggests the creation of a unified world map with the scale of 1 to 1 million, the million map. Even with the support of the project does not begin until 1913. Work continues on this grand map until 1987, when the United Nations, who was charged with the continuation of the map after World War II, stops work on it altogether. By this point in time, the entire world has been mapped and photographed in one form or another, and newer, more effective ways of navigation have become to be, none of which would be possible had it not been for the constant pursuit of mapping the world. As we move on in advances in navigation, we must take a look at the role of radio waves. This technology, although at the start not very effective, was used during World War I to track the locations of planes. Not as sophisticated as our current radar systems and GPSs we use, but still more effective than trying to read a map while flying a plane. Pilots would call in for direction, and their positions would be triangulated by two stations on the ground, and then that information would be relayed to the plane to make necessary course corrections. In the 1930s, the United States began to build its own style of radio wave guidance system for aircraft. This technology was called the four-course system, due to its ability to send signals in 4 directions for use in navigation. Each transmitter would send a single letter over and over in Morse code. One would transmit the letter A, which in Morse code is a dot and a dash. The other would send the letter N, a dash and a dot. The two stations would synchronize their transmissions so that each would transmit during the momentary pause of the other. As a result, If an airplane's radio picked up the signal of both transmitter at equal length, the pilot would hear a steady tone as the Morse code letters merged. If, instead, the pilot heard one louder than the other, he would know that he was not perfectly aligned with the radio station and would turn left or right as needed to smooth out the two signals. There were flaws in this system due to signal disruption, and it was especially perilous in mountainous areas where there were 5 crashes in 1 month from December 1936 to January 1937, where pilots mistook signals reflecting off of the face of mountains as the beacons and ended up crashing into them. Even with these issues, it was still a far better way to navigate and was the primary U.S. air navigation system for the time. In our current time, the greatest tool we have for navigation is GPS. The original idea of GPS was conceptualized by Ivan Getting and Shep Arking in 1960. The concept was to use 4 radio signals from a network of orbiting satellites to measure latitude, longitude, and altitude, with the 4th used to calculate discrepancies, making for highly accurate locating capabilities. Unfortunately, the technology required did not exist in 1960. The military commissioned the building of the GPS system in 1962. The process of getting a functioning system took until 1993. Due to limited federal funding, the satellite network consists of 24 active satellites and additional backups. It functions based on the concept of getting and arcing. One of the major struggles that led to the long delay was the need to develop an atomic clock small enough to fit inside of a satellite. The program has had many other delays, but was ultimately successful and is used as a navigational tool not only by our military, but also by our civilian population in the ways it was intended to be. The effects of this new technology on our society has had some great advantages. It has helped to make navigation as simple as asking your phone for direction and has made our skies a much safer place to fly. It has given our military the ability to guide missiles with exacting precision, helping to limit civilian casualties in war. There are also some concerns of violation of your privacy with the news that personal information can be tracked without your knowing by your cellular provider and the capability of our government to track your whereabouts at any given time. There are new products that are available, such as a total station, where you upload a set of building plans into a handheld rod with a receiver and can plot any point that you want with ease. And I'm very excited to see what the next evolution of navigation technology is and how it will better help our society. Thank you.